Hello friends, welcome to Truth of Physics. Today in this video I will discuss a very interesting topic, and that is the equivalence of Kelvin, Planck and Clausius statement of second law of thermodynamics. So in this video I am going to derive or establish the equivalence or the message these two statements of thermodynamics want to say us. Okay, the two statements are actually equivalent or saying the same thing. Okay, so that I am going to discuss detailedly in this video. So first we want to know what is this thing. The Kelvin Planck statement actually says us no process is possible whose sole result is the conversion of heat into work. Okay, it's clear, it is very easy. Okay, and the Clausius statement says us that no process is possible whose sole result is the transfer of heat from a body of lower temperature to a body at a higher temperature. Body, okay, to a body at higher temperature. Okay, because here two cases, and what is the motive? All right, how we will proceed to come to our conclusion, right? So we will discuss here two cases, and in each of the cases we will consider one statement to be false or one statement to be violated, and consequently we will see that the other statement will also be violated then. So then we can say that if first one is violated, so the second one is like, okay, let us understand with this example, or with the first case. Okay, so our case number one, I'm assuming that the Clausius statement of second law of thermodynamics is violated. That means from this figure you can see that the Clausius statement says is what no process is possible whose sole result is the transfer of a heat from a body at lower temperature to a higher temperature body. That means here you can see that it is easily violated here, right? It is a what? Carnot refrigerator, which is drawing Q2 amount of heat from a lower temperature reservoir, which is T2, right? This lower temperature reservoir to the higher temperature reservoir, right? It is higher temperature reservoir, so Q2 amount of heat is drawing by this Carnot refrigerator without expenditure of any work. There is no work, and here it is cleanly said that whose sole result, that means only result, whose only result will be the transfer of heat from this, right? So in this process, yes, it can be valid, but only when we will give some work to it, right? But there is no work here, so as a result the Clausius statement is invalid here, right? It is violated here. So we will see now, we will discuss that is the another statement of second law of thermodynamics, right? That is the Kelvin Planck statement is obeying or not here. For that we will use or we will consider another heat engine, and that is a Carnot heat engine. Okay, it is a Carnot heat engine, suppose, which is drawing Q1 amount of heat from the higher temperature reservoir and doing some work and just releasing the rest of the heat Q2 to the lower temperature reservoir. So the W is easily Q1 minus Q2, right? Now it is heat engine. Okay, heat engine. Now if we combine these two things, if we just combine these two things, then equivalently we can say that we can think it of like this. This is T1, this is T2, and a engine like this, which is the composite engine, which is drawing what amount of heat is it is drawing? Q2, which is going upward, and Q2 it is going downward, right? So its sole result will be just cancel out, so it will draw no amount of heat, right? That means I can use like this. This is drawing no amount of heat, but and here it is, here what amount of heat will be here? Q1 minus Q2 extracting, right? Q1 minus Q2 heat is extracting from the higher temperature reservoir, right? And this will work W, which will be equals to Q1 minus Q2, right? This thing. So this heat engine is doing work. What? This heat engine is taking Q1 minus Q2 amount of heat from the higher temperature reservoir, and it is converting the total amount of heat, right? This total amount of heat into the work. The work amount and the amount of heat that is absorbed from the reservoir is same, which is just contradictory to our Kelvin Planck statement. Here you can see no process is possible whose sole result, here it is sole result, whose sole result is conversion of heat into work. That means complete conversion of heat into work is not possible as a sole result. And what is happening here? Here only the thing that is happening, it is extracting the total heat and converting the total amount of heat into work. So this is completely violated by the Kelvin Planck statement. Kelvin Planck statement. So what we have discussed, what we have seen, if the Clausius statement, if we first assume that the Clausius statement is violated in some case or in some experiment, then the Kelvin Planck statement will automatically get violated. That means in a reverse process, I can say that if Clausius statement is true, then Kelvin Planck statement will also be true, right? So these two are equivalent, but I cannot say it properly, right? I cannot reverse back it, right? I cannot say that if Kelvin Planck statement is obeying, then the Clausius statement will also be obeyed. For that, we have to show another case, and that will be like this. We will first now consider the Kelvin Planck statement is not working or it is violating. Then, as a consequence, the Clausius statement is violating or not. We have to see that, and then we can say as a whole that these two things are just equivalent things. Okay. So our case number 2. Now we will first consider the Kelvin Planck statement of second law of thermodynamics violating. That means from this figure you can see that here also the T1 is greater than T2. Okay. So here you can see that the T1, there is an heat engine. This is a heat engine which is extracting Q1 amount of heat and completely converting it into work, right? Completely converting it into work, which is completely violated by the Kelvin Planck statement. So the Kelvin Planck statement is violated here. Now we'll consider another refrigerator. Okay, we'll consider another refrigerator, Carnot refrigerator. What is the purpose? The refrigerator will draw Q2 amount of heat from the lower temperature reservoir and give Q2 plus W amount of heat to the higher temperature reservoir. That means we are just giving this amount of work W to this. We are connecting these two things. This work done is given to this refrigerator to draw Q2 amount of heat from the lower temperature reservoir and giving this amount of heat to the higher temperature reservoir. Okay. So as a whole, if we now make the composite engine, then what happens? Then that will be looking like this. This is the T2, a composite engine. Okay, which will be like what? In the lower side, in this side, you can see that here it is only Q2. So this will be just Q2, and here this will be Q2. This will be Q2 plus W. This thing minus this, because this arrow is downward, so minus Q1. Now what is W? W is actually Q1, right? That means this will be simply Q2. So what is this? It is actually drawing Q2 amount of heat from the lower temperature reservoir and giving the heat to the reservoir at higher temperature without expenditure of any work. which is just contradictory to our clausius statement, right? No process is possible whose sole result is transfer of heat from lower temperature to higher temperature resultant. So it is easily seen that it is violating the Kelvin Planck, the Clausius statement, right? Clausius statement. So from case number 1 and case number 2, I can summarizely say that the Kelvin Planck statement of second law of thermodynamics and the Clausius statement of second law of thermodynamics is just conveying the same message, or these two things are just equivalent, right? So this is all about today's video. Hope this video is helpful. Share this video with your friends and take care of yourself. Thanks for watching.